In this question, we've been told that a man is driving a car on a straight horizontal road. He sees a junction called S ahead, and he knows that he needs to stop there. When the car is at point P, 300 meters away from S, so point P is the beginning of the journey, its speed is 30 meters per second. The car continues at this constant speed for 2 seconds after it's gone past P. So those are the first 2 seconds of the journey. The man then applies the brakes so that the car has constant deceleration and comes to rest at S. So it comes to rest at the end of the journey. Even without being told, I know I would need to produce a sketch. So let's go ahead and do that. As usual, our vertical and horizontal axes, vertical for velocity, horizontal for time. The first 2 seconds, we know we were moving with a velocity of 30. After that, there was constant deceleration until it got to rest. The time period for this constant deceleration is not known, so we're going to label this as t. It's an unknown value of t. And this will be our diagram. That's as much as we can do. For each stage of the journey, we've shown the time interval and we've shown what kind of velocity we had, whether it was constant velocity or there was some acceleration or deceleration. We've shown that the acceleration was constant by using a straight diagonal line. Part B of the question wants us to find the time taken by the car to travel from P to S. So, the time for the entire journey, from P at the beginning to S at the end. We know the displacement is 300. We also know that the time is the whole of this x-axis, 2 plus t. So let's go ahead and calculate t. If we know that the total distance is 300, we know the area underneath a velocity time graph represents the displacement or the distance traveled within that journey. So we'll go ahead and set up an equation. The distance of 300 must match the area of this velocity time graph. We'll use the formula for a trapezium. Half of the parallel sides added. So we have 2 at the top and 2 plus t down at the bottom, multiplied by the perpendicular distance between the parallel sides, multiplied by 30. So from there, some sensible rearranging, and we get something quite straightforward. 20 equals 4 plus t, t equals 16. This is not quite the answer to the question yet. We know that we need 2 plus t. So 2 plus 16 equals 18 seconds. The time for the car to undertake this journey, to travel from P to S, 18 seconds.